Hi there, this is Mrs McTaggart and we are going to be looking at the introduction to integration. This is the first in a whole series of videos. It will be quite a long one. I'm covering what would probably be 2 or 3 periods in class all in one video here, so I hope this helps. What is integration? Integration is basically the reverse process of differentiation. So, and to help illustrate it, I like to use this example here where we differentiate first and then we try to work backwards to see what our answer is. So if I asked you to differentiate 4x squared, you would times by the power to get you 8. And then that would become 8x, and then you would lower the power and it would just become 1. Let's change my pen style. Now if I give you this next example, we differentiate 4x squared, you would times by the power, giving you 8x, you would lower the power to just 1 again, and then the 10 thing would disappear. Now I started with 2 completely different expressions here and got the same answer. So when we integrate, how do we know we've got back to the actual answer we started with? Because integration is just reverse of differentiation. So to think about getting back the way how to get to 8x, well, the opposite of times and by the power was dividing by the power, and the opposite of lowering the power was increasing it. So we have to do that step first. So if you increase this power, it becomes 8x squared. And then you would divide by that new power to give you 2, and that would give you your 4x squared. On the same thing over here, you would have a 4x squared, but we knew there was an extra term at the beginning. But we have to put on this other little thing that we call c, which stands for a constant of integration. And that little c helps us maybe think, well, what if there was a number at the end of this expression? It could be that there wasn't one, and then in that case c would just be 0. But there are instances where you actually go on to work out what c is. So c has to be there just to take the place of that item that might have disappeared in integration. So what we've done is, working backwards, we're increasing our power first, and then we're dividing by our new power. So complete opposite of differentiation. So here it is in the jargon, in the notation, and there's 3 different rules here. I'm just going to make you focus on the first one. The first one says that to integrate, you take your power of n, you increase it by adding 1, you then divide by that new power. Where possible, we simplify and you add on the c. Right? A can be any old number that might simplify with the denominator, it might not. It also says if you are asked to integrate 2 terms like this, you can split it up into the integral of the first term, integral of the second term. Again, there's this plus c in the end. And also, if there was a number in the front, you could just pull that number out at the front, integrate, and then you can introduce a number k as a constant again at the end. But again, we still have this c as a constant of integration. I was once taught this poem, which I really liked, and when I first started teaching. Increase the power by 1, divide by this when done. Incomplete, it will always be unless you remember to add on c. This is the most important bit there, okay? To remember that you're incomplete if you don't add on c. And then my little way of just saying it when I'm talking to the class and teaching through it, my little mantra is raise the power, divide by the new power. So that's what I'll keep doing, okay? I actually probably tend to use the word increase instead, because I like the alliteration of when you differentiate, the power goes down, and when you integrate, the power increases. So I like that little alliteration going on with the I and the D. Right, let's get into it. Let's do some examples. So example 1. So this little kind of F shape is the symbol for integration. The minute you see that means you have to integrate here. dx, don't worry too much about this. This just always has to be at the end of the question. It just tells that we are integrating with respect to x, okay? So what we do is, the notation is quite iffy for this one. So the minute you integrate, that integral sign disappears. And then we just write equals. We write our x, we increase it, the power by 1, so we increase that to 6. We divide by the new power, and then you add on your plus c. Remember, incomplete it will always be unless you remember to add on c. Now nothing simplifies here, so we are simply done. That is it, okay? Let's do the same with the second one. So we're integrating. So we write down the 10x. We're going to raise that power by 1. So this will become the power of 5. Then we divide by that new power. Don't forget your plus c. Then we notice that 10 and 5 can cancel. They are both in the 5 times table, which will leave you with just 10 over 5 is 2. So 2x to the power of 5 plus c. Now later on we're going to be substituting in here, so it's really important that we simplify where possible. In other questions we're going to make sure we write things with positive powers as well. And so that's that one done. I would always urge you, do not try and skip this line. Do not try and go straight from the 10x to the 4 to the 2x to the power 5. You run the risk of making a mistake and it's really not worth it. Okay, so these ones get a wee bit tricky. We need to prep them a little bit first of all. So remember, a negative x on the bottom can come to the top. So this becomes the integral of 9x to the negative 4. And I've still got the integral sign, I've still got the dx because I haven't integrated yet. Now I'm going to integrate, so I'm going to increase the power, so it becomes 9x. Please remember, minus 4 goes up to minus 3. And then we'll divide by minus 3. Don't forget our plus c. Now 9 over minus 3 can simplify to just simply minus 3. And that negative power can go back down below and be written as x cubed plus c. So that's that one. Right, this one, please remember, anytime you see a square root, that's a power of half. But there's already a 3 there, so this is a power of 3 halves. Remember, the bottom number became the root, the top number stays put, so that 3 is staying where it is. So this is what we're being asked to integrate, so integration sign and dx are still there. Right, when you raise the power here, 3 over 2 add 1 is a bit like doing 3 halves add 2 halves. And that's the way I tried to get my class to think about it. 3 halves plus 2 halves. So this will increase to x to the power of 5 halves. And then this looks really messy, but let's roll with it. We're going to divide by the new power, which is 5 halves, and then our plus c. Right, please remember from that 5 that dividing by 5 over 2 is the same as timesing and flipping it to 2/5. So this is essentially what this says we're doing here. So we're timesing by 2/5, so it becomes 2/5 of x to the power of 5 over 2. Now there's other ways of writing this. You can write it as 2x. So I could write that as 2 root x to the power of 5 all over 5 plus c. So you can either keep the fraction out the front as 2/5, or you can take the 5 as the underneath of the full fraction. It's entirely up to you. Because I wasn't being asked to use any substitution or anything here, I would have left it as a bit of a mixture of these two answers. I would have written it as 2x to the power of 5 over 2 all over 5. So just watch this one. I don't know if anyone's noticed, but there is a kind of trick that the class start to pick up. This little 2 in the denominator suddenly became the 2 on the top line. The 5 stayed in the denominator, so what's actually happening is the denominator of the denominator becomes a new numerator. That's a lot of 8ers in there, but basically that 2 comes up to the top line. But you can always go to the side and do what I did in red pen and do your old change it and flip it from that 5 fractions. Okay, question 5. Don't be put off by the bracket. The bracket is purely here because I've now got 2 terms. I remember right at the beginning I said if you had more than one term you can split it up and integrate them all separately. So we're going to integrate the number 7. Now none of my ones have actually had me integrating a number yet. So integrating a number, can you remember when I asked you to differentiate something? If I told you y was just the number 7, when you differentiate you go dy by dx equals, and the number disappeared to 0. Well, a bit similar to that in reverse, if there's a number, remember that would have been a 7x, because if I asked you to differentiate 7x before, you would have times by the power, lowered the power, and it just became x to the 0, which was just 1, so that just became 7. So what we've actually got at the minute is that 7 is really 7x to the power 0, and when you increase that power it goes to the power 1. So the trick is, if you're asked to integrate a number, the x comes back in. However, I don't have x's in this one, it's a v, so it's going to be a 7v that comes in, and then 10v will become 10v squared all over 2 plus c, and that gives you 7v. 10 divided by 2 is 5, so 7v minus 5v squared plus c. Okay, so that's me kind of covered the basic integration questions. Now there's going to be a wee bit more of prep work involved. So in this one, later on you are shown how to integrate brackets with powers, but your natural instinct at this point should be to rewrite this as 1 minus 4t, 1 minus 4t. So square out the bracket. Now when we multiply this out, we get the integral of 1, take away 4t and 4t, so take away 8t, and then a plus 16t squared. Right, now we are ready to integrate. So integrate the number 1 just becomes t. Remember I'm using t's here, I was about to write x. This would go up to 8t to the power 2 all over 2 plus 16t to the power 3 all over 3. Don't forget your plus c at the end. And just to simplify and tidy this up, I have got t minus 4t squared. Can't do anything with your 16 over 3. And that would be your answer there. I would not bother trying to change that into another order. You're not going to be doing anything with it. So just leave it as is, okay? Okay, so as I said, some further ones. So a wee bit more prep involved in these ones. Although we have been doing it. But we might find some negative powers and things cropping up now. Okay, so integral of 4 over x cubed. So this is going to become the integral of 4x to the negative 3. We are going to integrate, so increase your power. Minus 3 goes up to minus 2. Divide by the new power, which is minus 2. Don't forget your plus c. Now in the simplifying here, that's 4 divided by negative 2. So negative 2. And I'm going to bring that x down below and make it a positive power. So there is our answer. Same with this one. Anytime you see a square root, that's a power of half. So this is the integral of 2x to the power negative 1/2 because I'm bringing it up to the top. When you increase the power of a half by 1, remember that is minus 1/2 plus 2/2. So this will become positive. So you'll have 2x to the power 1/2 all over 1/2 plus c. Remember, dividing by a half is the exact same as timesing by 2 over 1. So that 2 comes up and you're doing 2 times 2 is 4. We don't need the over 1. I'm tempted to rewrite that back as 4 root x and get rid of the fractional powers. So I'll just put a wee bubble around that to keep it separate. Okay. Number 9. Everyone's favourite, lots of fractions in here. So this will become 4x to the negative. Now the bottom number was the root, so the 3 is the bottom number. So this would be minus 4/3 for your power. That doesn't quite look like a 3. Okay, when you're doing minus 4/3, you increase it, you're adding on 3/3. So we've got 4x to negative 1/3 still, all divided by negative 1/3 plus c. Dividing by negative 1/3 is the same as timesing by negative 3 over 1. We don't really need the 1 though. So the 3 comes up and joins the 4. I'm also going to times by negative, so this will be negative 12. I'm going to take the x down below, and then that will be the cube root of x, because a power of a third is a cube root, plus c. Let's keep this separate again. Okay, I've just changed question 10 a little bit. So when you've got all over a term, we can split that up into the integral of x cubed over x minus x over x cubed. Sorry, what am I saying? X over x dx. And then simplify this down, so this is going to be the integral of x squared and the integral of 1. Now remember, please don't start integrating until everything's good to go. Okay, increase your power, divide by new power, so you have x cubed over 3. Take away, well, number 1 just goes to x, and don't forget your plus c. We're nearly done. 2 more to go. Okay, so, again, a wee bit of prep involved here. First one, I'm going to multiply out that bracket, nat 5 style. So remember, when you're multiplying indices, you add the powers. So this will be 2x, and then that's got a power 1. 1 and minus 3 gives you negative 2. Take away 3 and minus 3 will give you x to the power 0. Now you could write x to the power 0 as 1, or we can just leave it here for illustration purposes as x to the power 0. So when we integrate this, we get 2x, this goes to minus 1, all over minus 1. Increase the power, x goes to x to the power 1, all over 1, plus c. I have a 2 over negative 1 here, so negative 2, and I'm going to take that x below and make it positive. And then this is just take away x, basically. So it's another good way of showing why the number 1 goes to the x when you integrate it. Because remember that x to the power 0 up there was just the same as the number 1. And that's that one. This is another one where we need to split it up. This is going to be nasty fractions. So this is going to be x to the 4 over x to the half. Take away 3 over x to the power of half dx. Okay, so subtracting the powers, we have the integral of x. Now, 4 in terms of halves would be 8 halves. Take away 1 half would be 7 halves. Take away, just bring that one up to the top, so it would be x to the minus 1 half. And I'll squeeze in my dx there. Right, let's integrate. So when you raise 7 over 2 by 2, you get 9 over 2. So you get x to the power 9 over 2, then we divide by 9 over 2. Take away 3x, that would go up to the 1 half. And then we would divide by 1 half. And remember my wee plus c on there. Right, so remember dividing by 9 over 2, flip it, becomes times by 2/9. So there's going to be a 2 on the top here. I'm going to leave this as a power 9 over 2. And then that'll all be over the number 9. Take away now. 3 divided by half is 3 times 2. So that 2 comes up in times is the 3, to make a 6. And then that'll just give us 6x to the half. We don't need the over 1 on the bottom. So that's probably my most tricky one there on number 12. That was me done. I thought I had another slide there. This has been a lot, okay? So I hope it's helped. I hope you understand how to integrate. Just remember that little mantra, increase the power, divide by the new power, and you'll be fine. And incomplete it will always be, and remember, unless you remember to add on C. All right, don't forget. It costs you a mark if you forget it. Thanks for watching. Bye-bye.